Welcome to another video and welcome to this tutorial. So in this tutorial we are going to be taking a look at maximum, minimum and turning point of one independent variables. And if you are just coming to this channel, so please subscribe and turn on the notification bell. So in this, so we only focus on one independent variables for this concept. And what do I do what one independent variable? Suppose we have f of x equals to x. So this is an example of one independent variable. As if as this f of x can still be y equals to x, we know that the x here is the independent and f of x is the dependent. Okay, that is anything we plug in the function is our independent. So therefore the y is which is also f of x is dependent and x is independent. And looking at this graph, so how can we demonstrate the maximum, minimum and point of inflections in this? So if this point is 0, and so if a graph starts from here and it reaches this point, so let's say I name this point A, and it depreciates to point B, and it later rises to, so suppose this point is our point C. So in these 3 points, I want to show the maximum, minimum and the point of inflection here. So suppose the graph starts from here, so just like the intercept here, and it reaches this point. So this point is the highest point along the y-axis, which is the maximum. So while when the graph falls down, so to this point B, as it is coming down, so this is also the y, but here is the minimum part of y-axis. And if you check this, you see that so this one is neither maximum nor minimum. It looks like maximum and minimum. So we call this point inflection point, or you can call it point of inflection. Okay, so how can we now know that here is the value of maximum and here is the value of minimum and here is the value of point of inflection? So this graph is not limited to this, but I'm going to use only this graph to explain everything. So if this graph is coming down, suppose this is just like S, all right, and when this is coming, so it will coming, that is the graph is which is of highest order before, it will keep coming and it will be depreciating. So that is from maximum down to minimum, so that is negative, and for minimum it keep rising, so I can call that one positive. So why this point, so it's just like indicating the f of x, so that is the real function which is also the along y-axis. All right, so but how can we now get the maximum and minimum? So, and which I've already stated, so we need to follow this principle, or let me just say that the procedure for getting the maximum, minimum and the point of inflection. So the first one is, we are given a question, so let's say a differential equation, a differential equation questions. So what we are going to do first is we are going to obtain the derivative of that particular function. I mean, you obtain the dy dx of that function if we are asked to calculate the maximum, minimum and the point of inflection. At the first, the given question, you first differentiate it. Okay, so and the next thing is we are going to let that differentiation, which is the dy dx, I mean the derivative, to be equal to 0. So the reason why we do this is to just to get the 2 points, which is from the given question. We're going to get the 2 points, so or we can still get more depending on the nature of the question we are given. So then after we have gotten these 2 points, so the next thing is to obtain the second derivatives. So and that second derivatives, the purpose of doing it is just to get the maximum and the minimum. That is the value we obtain from where we let the y dx equals to 0. We are going to substitute it in the second derivative, and the negative will become the maximum, while the positive become the minimum. Okay, let's see this. If the square y over the x square equals to positive, all right, I mean if it is the positive value that we obtain, so and we are going to consider this as the minimum of the functions. As from the graph, we will just show, when it starts increasing, when the derivative starts increasing, so we are going to obtain the positive value, and which is the minimum. Then when we have the square y divided by the x square, so and we substitute the value where the value we obtain from the y-x, and the answer is negative, that is maximum, because from the graph as well, when it is decreasing, so it gives the maximum. So y for the last one, which is if you have the square y over the x square equals to 0, so and here is going to give the point of inflection. Okay, so that is when the square over the x square equals to 0. But is it that when we substitute the value so equals to 0, we are going to check that in the further process? Okay, and let's see example to beautify this. So given this, we want to compute the maximum, minimum, and the point of inflation. So in this problem, x cube over 3 minus x cube over 2 minus 2x plus 5. So let's say this one equals y equals to all this, or let's say this equals to y. So x cube divided by 3 minus x squared over 2 minus 2x plus 5. So from the procedure, the first thing we're going to do is by taking the derivative of this as it was stated in the steps above. So by taking the derivative of this, which is the dy divided by the x, equals to, we differentiate this, so this becomes 3x raised to the power of 2 divided by 3 minus here is 2x divided by 2. So this x is just like when it raised to the power 1, and we have minus 2, and derivative of constant value, which is 5, is going to be 0. Then we have the y divided by the x equals to 3, we cancel 3, we are left with x raised to the power 2, minus 2, we cancel 2, we are left with x minus 2. Okay, so here is the first step, or let's say the first procedure we have to take when we want to find the minimum, maximum, and the point of inflection. I call this one step 1. So the next step is we are going to let the y dx equals to 0. So, and why do we do that? From the graph, when it is coming from the highest, it turns. Okay, so that turning point is where the derivative equals to 0. So just say at the turning point, the y dx equals to 0. And when this equals to 0, definitely x squared minus x minus 2 equal to 0. So in this quadratic expression, so we are going to get two values. That was why I stated earlier that two values or more. So we are given polynomial, we are going to get 3. Depending on the polynomial, let's say it's a polynomial of degree 3, we get 3. But here is the polynomial of degree 2, we are going to get 2 values, or we can call this one quadratic equations. And here, if you have it as x squared minus 2x plus x minus 2, everything equals to 0. So here is a factorization method of quadratic, because minus 2x plus x equals to minus x. Okay, then I'm going to separate these two. So here we have x squared minus 2x plus y, this is x minus 2, everything equal to 0. So here we have x that is common. By taking out x, here we have x minus 2, here is plus. So there's 1 here, which is multiplying x minus 2, everything equal to 0. So we have x minus 2 that is common, and we have x and 1, which is their coefficient. We take the coefficient together and we take one of these, which is x minus 2 equal to 0. So from here we have factorized the given quadratic. Then the root are x equals to minus 1 or x equals to minus plus 2. So on getting this, we call this one the second step, which have obtained the two roots. While the third step is we want to obtain the real, the minimum and the maximum. Okay, so what we are going to do is from the dy dx that we obtain, which is x squared minus x minus 2, then we take the second derivative of this if we want to obtain the maximum and minimum. So by differentiating this thing again, we are going to have this as 2x minus 1. Now we can now substitute all these values, the value of x that we obtained in this second derivative, to get the maximum and the minimum only. So let's say at x equals to minus 1, what are we going to get? If you substitute the value of minus 1 in this, anywhere we see x, just replace it with minus 1. And we are going to get 2 bracket -1 and everything here equals to -3. So since this thing is negative values, which means it takes maximum, because anywhere we get negative in the graph, okay, so that is going to be maximum. And this being the maximum because it is negative. Let's see how to obtain the minimum. So when x equals to 2, we're still going to substitute this same value, which is 2, into the same derivative, which is 2x minus 1, and we get 3 for this. It means that for this problem, we obtain the minimum to be positive 3. So, and here is it. And why the last one, which is the point of inflection? To do that, we are going to let the square y over the x square equals to 0 as it was stated above. All right. So it's not that when we input the value and derivative, second derivative equals to 0, that is equal to the point of inflection. No. So we are going to let the square y over the x square to be equal to 0. That is 2x minus 1 will now be equals to 0. I think this is clear. So the square y over the x square equals to 0. Definitely, we are going to have 2x 2x minus 1 equal to 0. And by making x the subject, so we have x equals to 1, 2x equals to 1, and the variables are by 2. Therefore, x here equals to 1 divided by 2. And this half, which is 0.5 on the graph, so is going to be our point of inflection. And here is how to solve this first problem for the maximum, minimum, and the point of inflection. Again, negative is maximum, positive is minimum. So let's see the second question. Okay, for this one, if we are going to obtain the second, the maximum, minimum, and point of inflection, so we let this one to be y, and by letting this, we are going to check the derivative, which is y prime. So I change the dimension now. So we have y prime is still dy dx. So if we differentiate this, we have x cubed minus 3x. I'm going to be very fast here because I've done something like this earlier. So there won't be more explanation on this. So we know that at the turning point, this y prime equals to 0. I made the derivative equals to 0, dy dx equals to 0. So hereby we have x cubed minus 3x equal to 0. So and here we are going to get 3 values because the power of this x is 3. So by taking out x, we have x squared minus 3, everything equal to 0. Then x equals to 0 or x raised to power of 3, 2 minus 3 equal to 0. And by taking 3 to the other side, we are going to have x squared equals to 3. And taking the square root of both sides, so we have plus or minus the square root of 3. So this will cancel this, and x equals to plus or minus root 3. So on getting this, you see that we obtain 3 different roots: 0, plus root 3, and minus root 3. Hence, to get the maximum, minimum, and the point of inflection, so we take the second derivative and we try to put all this value in it. So, at x equals to 0, we have x equals to plus root 3, and we still have x equals to minus root 3, being the 3 roots. Then the second derivative of this, which is y prime prime, equals to 3x squared minus 3. Then by putting the first one, which is at x equals to 0, so everything becomes 0 and we get minus 3. And we know that for every negative value, that is maximum. Okay, so and for x equals to plus root 3, we have y prime prime equals to 3 bracket root 3 all square minus 3. So and here becomes 3. This will cancel this, as square and square root cancel each other. So and bracket is multiplication. So and everything here becomes 6, because 3 times 3 is 9, then minus 3, that is 6. So and at x equals to minus root 3, so we have minus root 3 raised to power 2 minus 3. and this equals to, from here, what you can just do here is, uh, this square will affect the negative like this. So this is just like minus root 3 multiplied by minus root 3. Minus minus, that is plus. Root 3 times root 3, that is root 9. And root 9 equals to 3. So that's what we have here, minus 3. And everything also equals to 6. That is, this plus or minus root 3 give the same answer. And we can consider both as the minimum value because these two are positive. And we consider them as the minimum values. So, and to obtain the point of inflection, as we did earlier, so that we are going to let this second derivative equals to 0. So from second derivative, we have y prime prime equals to 3x squared minus 3. And if you let this equals to 0, we have 3x squared minus 3. Then we transfer 3 here, we have 3x squared equals to 3. And divide both sides by 3, we have x raised to the power 2 equals to 1. So by taking the square root of both sides, we are going to have x equals to plus or minus root 1. And plus or minus root 1 is still this. So therefore, the point of inflection is plus or minus root 1. And here is how to go with this minimum, maximum, and point of inflection. Thanks for watching and wait for the next video. Bye bye.